Well, welcome, week 4, and we are going to today the objectives for this week. Explain how the cloud enables collaboration, business continuity, to discuss the basics of virtualization in cloud computing, and explain how to leverage virtualization in the cloud. So this week we have this assignment right here, and this is adding all of the previous, this is the assessment, adding all the previous 3 assessments into one paper. The assignment itself, that's the assessment. So the assignment for week 4, right here, is protecting information in the cloud, and explain how to protect information in the cloud. These are access control lists that are described here. And then the paper is a 5-page IWG formatted paper. Write a plan for a company that wants to migrate data storage to a cloud service. So I thought a better idea was for me to show you, instead of having you write a plan, to show you what it looks like to migrate data storage to a cloud service. So, what I'll do is I'll attempt to describe a company, a type of data, and so on. I've got some notes over here. So this company, it'll be a fictitious company, what type of data they have that they want to migrate. I'll describe that. Financial records, probably see who and what positions will need to access the data, and how you plan to create and manage the ACL for the data. And the plan should also outline rights management, in other words, admin, administrators, and so on, and then add citations. Okay, so this is the assignment, but I thought better than doing a 5-page paper. Instead, I could just show you how to do this, and you could write up a report on what I show and what I do. So let's do that instead. So what I'm going to do is kind of like a hands-on experience, but I'll just share my Zoom session. You can watch me do this, and then afterwards you can write it up as a report, as though you yourself had done it. And I think instead of 5 pages, I think 2 pages probably be adequate. So on this, because that's a long paper for it's not a big value add here, but so I think it'd be better for you to watch me try this out. So so first of all, what I'll do is I'll take this screen. In fact, I'll leave the screen here, and I'll just duplicate. I'll just leave the screen here. So write a plan for a company. So first thing, what we want to do is a company. Introduction to the company. Okay, so I mean, this is all fictitious. It's actually something I've been thinking about. So the company has financial records, and this company has to make those financial records available to the public. And so the company is one or more publicly traded companies. So that's the company. It has its own business, and its data need to migrate to cloud services. So what are cloud services? Cloud services would be the 3 that are most prominent are the Amazon Web Services. The second one would be Microsoft Azure. The third one, Google Cloud Services. So then you have to decide which, and my goal is to work on all of them and show you each one. So choosing a cloud service, so there's different costs and so on. Some companies are trying not to put all their eggs in one basket, but they typically organize services and separate them. So so it'll be financial records. All right, and the people involved, let's say accountants, would need to access the records. And then we've got to set up the access control list for that data. And hackle. And then the plan for administering it, okay? So step number one is let's work with Amazon Web Services. So here we are, we have to figure out how does, right here, how does Amazon store data? Okay. This is another type of information. It's called content delivery. That's content delivery. Content delivery is about files that need to be accessed. That would be a non-database type file. And it could be like documents. It could even be JavaScript files, believe it or not, that are on your website. It could be CSS files that your website includes. It could even be parts of your website itself. And these are all different ways of content that's static. Database is a different animal. And that's what we're going to talk about, migrating our database to the cloud. So what databases are available? Let's come down here and see what AWS has for database. And right here. So we click on this set of services. And these are all the ones that are available. So why are there so many services, Amazon services available? Well, it's because each of them has a different application of database, meaning it's a different implementation. It's a different ways of storing data. And so first of all, we have to ask the question, how do we want to store the data that we have? In this case, I want to have a relational database. And so let's look through these. I already know which one it is, but let's look through them and compare. So this one, Amazon Aurora, high performance managed relational database. So that's a good thing, a relational database. So this one, Aurora, is Amazon's version of a data. It's like their relational database management system that they own, that they created. The difference down here, and this is one that I'm thinking of here, is this one here hosts database management systems that belong to either open source or other vendors. It is relational database. So think of Amazon RDS as a host of database management systems that are relational database management systems. So if your data, let's say you're using MySQL at your company, this would be a very good possibility. There'd be probably no conversion at all. We just bring the database scripts into create a MySQL instance and import those. Or let's say your database is in PostgreSQL. Then we set up a PostgreSQL instance, or Oracle, or SQL Server. That's Microsoft SQL Server. And MariaDB, this is kind of recent. It's open source. So this might be the migration path here. If your company, if this company And let's say it already is. So the answer is we're going to do Amazon RDS because let's say I've got a MySQL database. My company has a MySQL database that's on our own servers and we want to put it up in the cloud. Well, this would be the option right here. So once again, Amazon RDS is a hosting of other database management systems, whereas Amazon Aurora is their own version of a database management system. And I think, if I'm not mistaken, that they cloned the open source of MySQL and created their own. Let me double check on that. So as it turns out, I don't see that they cloned MySQL. I think they built it from scratch. So their goal was to compete with MySQL. There was so much MySQL out there, databases, that they wanted to, so they designed it to be compatible with MySQL or MySQL, better, MySQL Workbench and so on. Amazon claims 5-fold performance improvements on benchmark. So they wrote their own code. They made it compatible with MySQL, and then they offer it as Amazon Aurora. So why don't we go with that? It's compatible with MySQL. Well, I think that's a good idea. We might be. It is the fact that it's compatible with MySQL. Let's say our database that in this example is coming from a MySQL database that we've hosted. Then that would be a good migration path, frankly. But here's the other end of the story. This one I can do for free, and this one I can't. So, so here you have Amazon RDS 750 hours for free. So I don't see that Aurora is on the free tier. Nope. Okay, so given that, we'll go with this because this one's not free and this one is 750 hours. So MySQL, yeah, we're going to be 1/5 slower. I get that, but it's free. So this will be our choice of the database management system to which we will port our data and for which we'll set up our ACLs also on that migration. So what are some of these other things? Elasticache is a memory caching system, fully managed ledger database. You know, the fact that it's a ledger, that sounds interesting because we're dealing with financial data, but not in this example. Amazon Redshift for data warehousing, once again, interesting place to go for if it were a data warehouse. That's for BI and data analytics, would be good. This one is no SQL database. This is not the type we're going for. We want SQL base. We want to be able to query it with SQL. This is for a no SQL database. I think this would be like for JSON type files saved. Not too sure about Cassandra compatible databases or TimeStream. This is a fully managed time series database. Not sure what that is. Fully managed document database. That's interesting. If we were to do like spreadsheets, a big repository of that. Neptune's graph database, database management system, on-premises database management, VMware. That's for virtual servers, as you know. And look at this, Migrate database with minimum downtime. Well, this is looking interesting. Database migration service. Wow, let's see here. Let's learn more. This is exactly what we're trying to do. AWS Database Migration Service. Okay, migrate your databases to AWS with minimal downtime, more than 200,000 databases migrated using AWS Database Migration Service. Wow, let's learn more. Okay. So, AWS Database Management, let me pause it. This is a very interesting option because you can migrate your database and keep them running. So I like that. And the source database remains fully operational during the migration. So that's a great thing. Hook up two databases, make them synchronize, and man, the transition to a new database, that's pretty good. I like that a lot. So let's read a little bit further though, because this service has a cost to it. If you are migrating to these particular databases types, then you can get this service for free. But keep in mind that all of these are not free databases. Let's just double check. Free tier database. So we got DynamoDB. Look at that. There, free database and free database. Wow, that's kind of interesting. Because here's the free tier of database. It's got Redshift, 2 months. And there's the database migration service. That's what we're looking into right now. So Redshift and DynamoDB. So let's see, here's the migration. Redshift, DynamoDB. Great, this is looking good. Free tier for this, the database migration, if we go to Redshift or DynamoDB, which is, let's see, free tier. Huh, this one's always free. Nice. Free trial. So 2 months of Redshift. So we're kind of designing what database we go to, database type. We duplicate this and then come back here to the list of databases here. So DynamoDB, it's a managed NoSQL database, and then Redshift is data warehousing. So these are, if we want to stay free, I'm kind of just looking at the possibilities here because I've already said we're going to go here because it's MySQL, but then we just saw that Amazon Aurora has relational database, but then we came here to database migration services, which is good if it works with Aurora. Oh, but Aurora you got to pay for. Redshift, not paid for. That is data warehouse, and this is NoSQL. See, Amazon Document DB. I don't think that's in the free tier. Let's see, Document DB. Nope. All right, we're kind of narrowing it down here to a data warehouse or a NoSQL database if we want to use this system, which sounds very interesting. So let's just double check and make sure. I kind of already know I'm actually changing it on the fly. The database. Let's just look into a little bit about NoSQL database just to be sure that the database that we have can't work in this environment. And we can talk about data warehouse here in a second. So I'll open this new tab. Here we go, Amazon DataDB, pause. DynamoDB being NoSQL, at first kind of scared me off. Let's say my application was definitely SQL based, so that would definitely be an issue. But let's say our company is considering a rewrite of our code that, let's say our application has been around for 20 years. It was a database. It was an application running on a MySQL, using a MySQL database. Let's say we are considering changing how we structure our data. Let's say we're open to that, at least on this migration. And let's say that, so we're open to this. Now, what's interesting, look at the companies that are using DynamoDB: Lyft, Airbnb, Redfin, Samsung, Toyota, Capital One. So they're using this NoSQL database. Performance at scale, the amount of its ability to scale, but this is cool too. Serverless, so we don't really have an instance of a database to manage at all. That's nice. Serverless is very interesting for both database serverless, but also application serverless. So let's say our conversations at our company have been, we've been saying, you know, we've been thinking about going serverless. So not only are we thinking of moving to, let's say those are the conversations, because frankly, that does interest me. If I were a company, if I had my own company, I would definitely be interested in serverless, and I would be looking into it. So because it's less expensive. If we can architect our application with serverless, and that's just the regular like instances like virtual servers. Let's say we don't need virtual servers, because if you go serverless, you don't need virtual servers. You know, we spent a couple of weeks talking about virtual servers, and now we're, and in one of my discussion posts I mentioned we're going, you know, the real trend right now is going serverless. So if you're going to develop applications from scratch, you want to go serverless. So so that, and then here's the serverless database, the correlating concept. Serverless for your application and serverless for the database. You have to solve both, and this is looking quite good. Now here is interesting because this ACID transactions are ACID. It stands, I don't know, I forget what it stands for. Hold on. So ACID means atomicity, consistency, isolation, durability. Okay, so basically what it means is if your servers go down, you don't lose. It's exactly right. All these different applications adding, updating services or data on your database. If the server, wait a minute, it's serverless. So if there is some sort of failure, the state of your database is perfect, and they keep track of it. So it's interesting because you can create full backups of hundreds of terabytes of data, and you can literally go back in time, preceding 35 days with no downtime, recover to any point in time preceding 35 days with no downtime. Now that's amazing. It's an amazing rollback that you can anytime, if some failure happens, for that matter, you know, here's an example of a failure. You deploy your application, you don't realize it, but there's a serious bug in your application, and that bug actually ends up destroying data or deleting or updating when it should or whatever. That's an example of you saying, oh crap, we've got to roll back, and this here gives us 35 days to roll back to. So basically what I'm saying is, this is interesting. Serverless web apps, definitely where we want to head with our design. Build powerful web applications, automatically scale up and down. So here we have the DynamoDB. This is Lambda. This is what I was talking about with where your application is serverless. And then you sit on top of that an API gateway. So the app makes a REST API call to the endpoint that's here in Lambda, and then that goes to this database. This is kind of like the very interesting architecture of current, if you want to start developing apps. So serverless data, serverless code. Here's a clicks link to get local weather information. Hits the API gateway front end code for. So, and this is the S3 where you host your I love this picture. Where you host your website. There is no server in this whole model. That's what I love about this. S3, it's just like a folder of files out there. So here we host our website on an S3. S3, that's an Amazon service that just is a collector. It's a content management system. It's really just where you put files, and that can be, so we could direct our website to an S3 file, and so it's HTML and CSS files and JavaScript and so on, and that was my wife, so I felt I had to answer it. All right, I love this configuration. REST API call to endpoint, hosted website on a document management system. There's no web server on this. Let's see. I'm wondering if we can, we can just put HTML on there and CSS, it's static. But I don't think that we could put like a server, like a script that gets invoked. Let's see. I'll have to figure that out, because like a PHP server or I'm having a brain lapse. Hold on. Okay, Python. Let's say we have Python script in our code that we put there on S3. Can a Python script be run on S3? So can you run scripts from on Amazon S3? And so this is where you grab the scripts from GitHub or the Amazon S3. So here we are running scripts from Amazon S3. You can run different types of scripts, including all of these, including PowerShell. And there's Python. So these are all script. So that could be in your website there on the S3. Or maybe this is actually, maybe you're running on EC2 and the saved files are in the S3. So that's a different architecture. Yeah, so I think the answer here is if you have a server, you can invoke Python from your server. So when you have a server, it's like an EC2 instance. That's EC2, that is the nickname for the Amazon Web Services virtual server service. So that is not serverless, that is server. But the files, they're just saying you can host the files. Literally, it's like a file. You can host the files, you can host scripts, you can stage them or plant them or copy them, whatever you want to call it. Those scripts can be there, but you can't invoke them. You have to invoke them from a server, which is on an EC2 instance. You can't, this invocation of that server, that service, you're pointing to that service that's physically located on S3. So long story short, and here's Ruby and so on. Long story short, so let's get rid of that. And we'll get rid of that. And that. And we already know about that and that. Long story short, coming back to the migration, we got that. Oh, this right here. So if our model was such that we can put the files, this is serverless model here. Let's see, the static files, we invoke the API gateway, it calls serverless, and then there's our serverless database. So this is actually looking very good. Let's go and look what other kinds of models they have. Mobile backend. So we're proving DynamoDB, whether or not we want to go from MySQL database to NoSQL. So let's look at this architecture. Okay, so this is So another thing DynamoDB can do is work with mobile apps. Mobile apps that are just dependent upon data being updated. And we've got this interim service here, AWS App Sync, connects to the data sources and displays, for example, in this example, chat activity, messengers user. And then Amazon Incognito, user authentication, and retrieves credentials. So that's it, kind of interesting. It's pertinent to our assignment a little bit when we talk about ACLs here, rights management, authentication. So that might be a consideration. And third and final microservices here, architecture. Here's a third use case of DynamoDB. There it is right there. This is Lambda serverless. This here is a service of AWS called Kinesis. And Kinesis is can load it's like real-time streaming information. Real-time streaming. So for example, in this case, it shows these are tags. And so pretend you are monitoring tags in, let's say, Twitter or and monitoring that, and then triggers this Lambda database. Here on the back end, social media trend data immediately available for business users to query. So this is an interesting application. You're monitoring all these tags and what maybe quantity and so on. Another interesting application. So, so long story short, this is kind of looking good. So this key value store that's actually how it's stored. And it's not like a relational database query. They're the key value pairs. So I was curious to know how DynamoDB saves its data, because when they say key value store, it makes you think of Json. And let me show you an example JSON file format. So JSON is a textual way of putting data. You can put objects in it. So this is like instead of a relational database. This is like if you had to export a relational database to, for example, it's kind of like if you exported that to a CSV file. But this is actually better because you can export the data in a format that it kind of brings a schema with it. So you can export objects. This is like the syntax of it. Arrays of objects, values, strings, and so on. So this is JSON. And this is actually how DynamoDB will talk. So here's an example of JSON. So that's the name of the object. It's made up of a title, and which is made up of title, which is made up of gloss entry, and so on. You can see. So when it says when it talks about this, let me come back to it. When it talks about this key value store, they're kind of this key and the value. So the key is this. The key is that. The key is what's before the colon. That's the key. Key. And so this is a whole relationship of data. So there's the key. There's the key. This is the value. So key value, key value. So when you reference this key, and so this, if you're expressing it in XML, it would look like this. And this is what the data would look like. So you can kind of see there, JSON and XML are two different ways of representing data textually. JSON is becoming more popular than XML. Because for one reason, you have to do open. This is like HTML. XML is open and close, open, close. See that? But over here, you don't have that with JSON. So these are JSON files. This is what a JSON looks like in this. Looks like this is what it looks like in XML. So Dynamo uses right here. So Dynamo, this is the application. This would be kind of like the serverless application, and it talks to the DynamoDB. Okay, so it's like this. What we're seeing is this is the application talking to DynamoDB. So here, there's the application, it's serverless, and we talk through an API, application programming interface at that. So the low-level API uses JSON as a wire protocol format. JSON presents data in a hierarchy so that both data values and data structure, see that data structure, that's key, are conveyed simultaneously. Data and structure conveyed simultaneously. Name value pairs, there it is right there, are defined in the format name : value. See that? The data hierarchy is defined by nested brackets of name value pairs. Okay, we just saw that a second ago. See, this is nested in here. And so there's name and value, name, value, name, value. And so that's, I just wanted to expose that all to you because this is pertinent. Not there. Yeah, good. All right, there we go. So there's the name value pair. So I'm basically liking what I'm seeing. It's JSON. I'm liking that it's kind of like the way it's serverless, and this is very appealing in our migration. So not only are we migrating data, now I'm even thinking of re-architecting it. So a migration. So back on our journey, we started way back here and thought, oh, wow, let's just migrate. And then we go, yeah, that's what's cool. Migration service, what's cool about it is you can keep this thing running for 6 months at a time. No, I didn't mean to say that. You can actually, it's free for 6 months if you use these. That's what I meant to say. But the nice thing is the source database. So let's say we're a company and we need to keep our operations going. We don't have time to take it down. During the migration, remains fully operational. And so anyways, so minimizing downtime. So you migrate your data to and from. So that's really appealing. This migration service is very appealing. Now, what's also very appealing is like what we're looking into is like re-architecting our whole application. It's an old, let's say it's a 10-year-old, 20-year-old application. It's running with MySQL. Well, wow, there's so many other options now. And so we're not only migrating, we're thinking of rewriting and re-architecting it when we go into the cloud. So that's very appealing. I'll put some of these links in our chat so that you can just click on them. I don't know if this shows up on the screen. Put that link, and then here's the database migration service. That was interesting also. And then the DynamoDB architecture, liking that. So let's see, are we still free? Let's see, Amazon, yeah. Let's see, database. Clear all filters and do it again. Come on, guys. Used to have free. Why isn't this working? Couldn't delete this out. Do it again. Okay, here we go. Database, boom, and there we go right there. So we're getting away from our old architecture of MySQL base. We're thinking of going to DynamoDB. I like that a lot. Let's see, always free, sweet. So our serverless, wow, free tier, that's so attractive. And then we've got this migration, 750 hours of migration. Wait a minute, it says always free. Minimal downtime. Okay, so why does it say 750 hours and then it says always free? I don't know. That's weird. Huh. All right, let's roll back, pop back to this here. And so we're leaning towards this DynamoDB. Go away from MySQL, go here. And then this was another option that we're looking at for this migration. This Redshift, it's data warehousing. That's a different application altogether. That's not like the type of application we were looking at with these architectures. You know, these are full-blown apps. These are apps that do different things and work with DynamoDB. So those are serverless apps going on right there. See, it's kind of cool. Each of these. Let's see, this one doesn't show Lambda in it, but this one does, and that one does. Lambda is the serverless service that Amazon makes available. But back to this Redshift. So the question we ask ourselves, hey guys, do we need a data warehouse? And the answer is actually no. Our application is for, this application needs to be an app. This is Amazon, this Redshift is a different way of storing data. So a data warehouse is very much different than a database. And that's what this is about. This is about a data warehouse. You use a data warehouse in order to do data analytics, or in order to do AI. So, and our application in this case is not, we're not doing data analytics. We have an app. So you might ask, what's a data warehouse? You probably have had a class in that before. So let me tell you a little, just remind you. So what is a data warehouse? It's a central repository of information can be analyzed to make better informed decisions. Data flows into a data warehouse from transactional systems, and our app is going to be a transactional system. And so this is, data warehouses is like data about data. It's like metadata. It comes from relational databases and other sources, typically on a regular cadence. Business analysts, data scientists, and decision makers access data through business intelligence tools, SQL clients, and other analytics. So that gives you a reminder of what a data warehouse is. And then ours is a transactional system. In this case, this is a nice little correlation between, or comparison between data warehouses and a database. So it's like apples and oranges. Okay, you can house a data warehouse in a relational database, but the schema is different. Okay, so it's not like the transactional database schema. It's a different schema. So just as a reminder, data warehousing has a different schema altogether than a transactional database. It you can take the data from a transactional database and bring it into using ETL. Let's see, ETL stands for, you could see exchange, transfer, and load. Extract, transfer, transform, and load. Extract, transform, and load. So a data warehouse is populated using an ETL process, which actually reads data from your transactional database and then writes it into your data warehouse. Now, the reason I want you to be aware of that, just because I just want you to remember what it is. And our application is not a data warehousing application. These ETL processes that are used to populate a data warehouse constantly go. They're monitoring the data that's being added to and updated in the transactional database. And we've got our data warehouse over there with a different schema altogether. It's not a transactional database schema. It is, for example, and these are different sample schemas for data warehousing. One's called the star schema. The reason why it's a star is because you have this fact table in the middle, and these are dimension tables. Basically, it's like metadata about data. In a spreadsheet, you can do things like this. Let's see. Oh man, we have another. What's the name of that? Hold on. All right, it's a pivot table. Pivot table. All right, so Excel spreadsheets or spreadsheets in general use a pivot table in a similar fashion to how a data warehouse uses data, in that it's data about data. That's what a pivot table does. It looks at all the data and makes observations about the data. So a star schema, data warehouse database, you also have a snowflake schema, and even some normalized data. By the way, it's fourth normal form, first, second, third, fourth normal form for relational databases is not applicable in general to data warehouses. The relational database is designed for first, second, third, fourth normal form, but this one does have some normalization going on with the snowflake schema, fact constellations, and so this is what is a typical type of database schema. All right. So that's data warehousing, and that's Amazon Redshift, and we're not a database application, and we're not a data warehouse application, so we're not going to do Redshift, but we are transactional. You can be transactional with the Amazon DB, because in fact that's what its strength is, being transactional, really fast scaling. So you don't have the slowness of the relational database management system to be in the middle there, slowing things down. You go right to data, and that's the interesting thing about this DynamoDB and that API that we saw a second ago. Construct. Let's see. I think I dropped it. Oh, yeah, I think I dropped the page that had the construct. Yeah, I did. DynamoDB architecture. So anyways, this is looking good. We're going to use database migration services. We'll go ahead and do our conversion. It'll give us enough time to, because we can do this in parallel, we can keep our old system going, give us time to rewrite our applications in a serverless model. When I say serverless, I'm just talking about that Lambda. We've got to rewrite our applications to be serverless, and then our database will be serverless also. So this is looking like the route we want to go for our assignment. Okay, so that's the ending of the analysis of the services that we would want to use in order to migrate to our company to migrate data storage to a cloud service. That's just Amazon. We're going to use a migration data service. We're going to use this to go to a different format, DynamoDB. We'll rewrite our applications in Lambda. Let's talk a little quickly about Lambda. All right, Lambda is serverless. You do have code, but you don't have servers. When I say servers, I mean you don't have virtual servers. You obviously don't have physical servers. You don't have virtual servers. You don't have like operating systems of Windows, of Linux, of Mac, iOS. You just don't. It's serverless. So you have to rewrite your code to be serverless, and you have to write in Lambda. So you can run code for virtually any type of application or backend service, all with zero administration. Very appealing. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. That's nice. Scaling is a nightmare. You know, to set up in Amazon, you have to set up EC2 and then you have to set up scaling, and it takes forever to, well, it doesn't. I mean, it's designed for this. So, you know, when you need a new server on the fly, it takes a while to provision those. So anyways, this is kind of a nice thing to do with, instead of just porting our application right over and having to set up servers. So one second, let's see. So this Lambda is pretty cool. Don't have to provision servers or manage servers. So this is not replacing database servers. This is replacing code running on virtual servers. Okay, so no servers to manage. So in other words, you don't have virtual servers that are running Linux or running Windows, or so that's kind of cool. No servers to manage. Great. Continuous scaling. That's nice. You don't have to worry about setting up these virtual servers and automated provisioning to scale up, things like that. So that's nice. Sub-second metering. You pay only for the compute time the second that it's running. You know, there's no, it's just pay for the run rather than the server or consistent performance. So this is the Lambda service. So you can either upload your code to the AWS Lambda or write the code in the code editor. By the way, I've never done Lambda development. I've wanted to, and so so this is really intriguing to me. And you can set up your code to trigger from other AWS services, HTTP endpoints, or in-app activity. For example, you could have your code just sitting there, and something externally triggers it. I mean, externally, I mean like from another server, or I mean like from another service, like across the internet. For example, let's say we have this. Let's say we have this web service out there that collects. In fact, this is actually the application I want to talk about. We've got this service out there. Let me bring it up. All right, let me tell you about this service. In fact, let's just say for the sake of discussion that this is the part of the application that I'm wanting to migrate to the cloud. Let's say I've got an application that's running in, let's say, MySQL database, and I think, oh no, I want to change that. We're going to migrate to the cloud. Let's say we have it running on our own local Linux server, and we decide, you know, what's new and great. Anyways, so this is an example of a service that's happening all across the internet. This is actually happening by the Securities and Exchange Commission. And this service here is a place where all publicly traded companies upload their financial data to. And it's by law. if you're publicly traded, you've got to submit your financial documents to us electronically. You have to do it in a special format, and you send it right to our server, and you've got to do it several times per year. So this here is a streaming, it's not the home page. Let me just bring up the home page for you. You just kind of see what the home page looks like. So this is SEC homepage. This is one of the things that they do, and that is to receive electronically the financial statements of publicly traded companies. And why do they do that? Because it's part of them having to, publicly traded companies have to be transparent about their financial statements, especially now since a couple years ago when we had that, can't remember the name of the company that went under. Since that time, this has been very, very important. So let's submit electronically. So this service is going on now. You can actually search for example, Apple Inc. We can look, hey, Apple, when did you upload your financial statements to the SEC? Let's try this Apple. Let's see, company name, Apple. Let's see. Vector search home. Let's see. Search by ticker symbol. ABL. Dang, I'm having a hard time here. Daily filing time. All right, so see Apple Inc. This is probably it. Yeah, this is it. Okay, so this is, hey Apple, what financial statements have you uploaded to SEC, the Securities Exchange Commission? And here they all are. And these are the different types of filings. I'm not even sure what a type 4 is, but an 8K, and then down here 10Q. This is a quarterly one. Anyway, so all this data comes in. Let me show you. Let's see if I go here to documents. So then the files come in here, and this is HTML files. Then right in here is XML files. See that? That's data. So that literally is the data, different types of data that describes this company's financial statements. So in this case, it's Apple. So so here you've got all this data. Now, this is in XML format. So let's say we don't like XML format. Let's say in our application, our Lambda application, let's say what we want to do is set up your code to trigger from other AWS services, HTTP endpoints, or in-app activity. So let's say we want to set it up so that anytime that anyone uploads their data to, see this, so this is an RSS feed. We can subscribe to it. So this basically an RSS feed means that the minute that data comes in, we get alerted. So let's say we have our AWS Lambda service sit there and monitor. See right here, set up your code to trigger. So our Lambda code will sit there and wait for somebody to upload data to their financial data. Using our RSS feed, they'll sit there and monitor. And have you ever heard of RSS before? I can't forget what it stands for. RSS. Let's see, RSS stands for really simple syndication. It basically is a way to export, broadcast, have this little feed here that broadcasts, hey, we got new data. And so what we're going to do is we're going to sit there and monitor this RSS feed. And the second that somebody uploads some data, it's not just Apple, it's any any company uploads data, we're going to monitor that and trigger. See, this is going to trigger right there. It's, oh, wow, new data triggers our Lambda function. Now, Lambda function, what we can do is we can just do our Lambda function, and what our Lambda function can make, maybe what it can do is can change this XML format to This is the RSS feed. This is not what I want. I want to look at the document here. Where is it? Here. We got this XML coming in, and we snag it, and we actually convert it to JSON. Why do we convert to JSON? Well, here's a little tidbit on that. Converting it to JSON, why do we want to go from this XBRL? By the way, the XBRL format is the XML format of this particular XML file. If you look at the XML file, this file here it's an XML file, but it's basically the XBRL formulation. It's basically the XBRL is really a XML format for businesses. So this is actually for financial information. Anyway, so here, what we'll do is we'll convert it the XBRL format, which is XML, to JSON. Why do we want to go to JSON? Because we've got this DynamoDB, because DynamoDB likes JSON coming in. So we massage the data. We react to the RSS feeds that they're listening to the SEC. Some company transmits their data, their financial data, to that server. We get notified, oh, RSS feed. Then we trigger and say, okay, go grab that XML, then convert it from the XBRL format to the JSON file format. Why? It makes the XBRL data easier to consume. What does it look like? So this is what the XBRL looks like, but then this is what the JSON looks like, the same thing. So this is XML, JSON. Remember how I was talking about JSON, the value of it? JSON's like the new way to go for transmitting data across the internet. So we're going to convert it, the XBRL, we're going to convert it to JSON. We'll store it in our, where'd it go? In our Dynamo database. And it'll be our Lambda function that all it will do, our Lambda function can just do a conversion. That's all it does. It says, oh, you got some, it basically does this. You got XBRL? Oh, okay. I'm going to convert you to JSON. It'll do a conversion, and then it'll also store it in the DynamoDB. So we'll end up having a JSON database of all this financial data for all these companies. It'll be in JSON, it'd be nice. Anyways, so that's one operation we can do. Once we get into there, we can maybe have other operations that people can query that data using an API gateway, you know, maybe a different thing. One thing is to insert it, another thing might be, I don't know, to analyze it, for example. Somebody can call us and then we can do an analysis of some of that data that came in. For example, those are some ideas. Anyways, all right, so this is looking good. We got the XBRL to JSON converter. That's our system. We're going to use this database migration. Really, in this case, we actually don't have an existing database we're going to migrate, but we're actually going to leave that SQL database that let's say we had it in MySQL. We're going to leave it there. So technically, let's see. I wonder. I don't know if we can migrate. Let's see. Learn about source and target. I wonder if you can have a source MySQL and then a target. Source and target endpoints. The source is MySQL, and then the target is a Dynamo. I don't know if you can do that. This is the migration service, but again, this assumes that all our data is already existing in a MySQL database that we're then going to convert and keep in sync with the DynamoDB JSON file format. Sources for data migration. Look at that, RSS. Wow, that can be a source. Well, that's interesting. We were just looking at RSS. What is this? Oh, this is just an RSS. I'll forget that. This is just an RSS feed for this information. So you're going to keep track of whether or not this information here changes. I don't know if I can. Kind of cool. Links right to the Amazon website. So on-premise AWS EC2 instance, no, we don't have that. Oh, look at that, you can come over from Microsoft Azure. That's cool. Or another RDS instance database, Amazon S3. This would be it. If we had that. Oh, no, that wasn't it. This one. This would be it if our database were MySQL. And in this example, I'm saying that it is. This would be the source. Okay, so this would be the source. So it would come from MySQL compatible database. Then, how about the destination? Oops. So we got the source can be MySQL database. Now, what about sources? Targets. Here we go, targets. Is there DynamoDB? Yeah, there we go. Ta-da! Okay, so this would be the DynamoDB. So if we were just converting MySQL to DynamoDB, this would be it. This is how we would use the migration AWS database migration service to go from MySQL to a DynamoDB. If we already had that database set up, this would be good. I think. Question is, let's see, it probably converts it to JSON. So that would be what we'd use if we had to port all our data, which we would in this application. And then going forward, maybe we would just use that other service, that this one where it would trigger the RSS feed would trigger here, and then it would trigger, and we download XML, we would convert it, and then put it in the DynamoDB right here, convert DynamoDB. So going forward, we populate the DynamoDB with this ongoing, this automatically triggered service. All right, so let's see. So I'm feeling really good about all that. We are re-architecting our application. We are going from, let's say, a server, server-based, where we have our apps running on a server, and they are reading and writing to a MySQL database, and we're moving to the cloud, and we're going to convert to serverless, get rid of our servers, and that when we get rid of our servers, we actually dump all our application code that we've been writing for that. And I get that. So that's the old system. The new system will work with Lambda. We'll code and create Lambda. Yeah, migrations. Yeah. Here it is right here. Boom. That's nice. Zero downtime migration. Migration solutions. So this would be like an example of what our system would look like. We've got our apps running on our local servers, running on MySQL database, and then listing data, insert, update, deletes. Option 1 or option 2? Option 1, use the migration service. Option 2, anyways, it's kind of cool. How to port zero downtime. That's such a, it's a great thing to be able to sell. Go ahead, come to the cloud. Zero downtime on your database and your application, and we'll get you up and going for free. Like, wow, it's a great sales pitch. Amazon DynamoDB. Getting started. I thought I would see. Oh, see, kind of curious to know what Lambda functions look like, but let's just not worry about that because we're just kind of talking. That's kind of extraneous. We're kind of talking about moving data only. So, all right. So I feel really good about that. So good that I think I'm gonna get rid of that, and then this, and then the free tier. We're gonna go up to the free tier, right there. Kind of like that, and then now let's see, get rid of this, 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 and this. Now I promise to also run through this with Microsoft Azure. So let's just say we're doing a comparison here of all these different services, Google-based services. So Amazon obviously makes it very easy for us to convert and move our database to them. They make it very easy. Data migration services and so on. You can stay up and running. They got serverless, et cetera, et cetera. They've got free tiers. Make it very easy. Well, let's just see what Microsoft Azure has to offer for a similar thing. So let's say we're open to talking about going to Microsoft Azure. And instead of Amazon AWS, maybe it's Amazon's too expensive, or maybe we have a relationship with Microsoft we want to maintain. So the question is, what does Microsoft Azure allow for to compete with the all right, so Amazon. Yeah, we know what we want. We want serverless, and we want non-SQL. So here is Microsoft Azure. Microsoft Azure wants our business too. So question is, we know the architecture that we want: serverless, serverless code, and serverless database. Now, what does Microsoft have for serverless? So let us look to see, do they got Kubernetes, containers, Azure SQL, database. They like their relational database, so they can make lots of money with that. App service, hardcore, patch-on balance. That might be their serverless. And yes, they have serverless. Okay, go serverless, build apps faster without managing infrastructure. Oh, that's so appealing. Oh man, this gives me goosebumps. Yeah, who wants to manage infrastructure? Who wants to manage servers? Who wants to upgrade and patch them? Oh my gosh. So let's go serverless. So increase developer velocity, definitely. Boost team performance. All right, serverless Kubernetes. Wow, that sounds interesting. Didn't know you could do that. Let's create serverless Kubernetes-based applications using the orchestration. Man, I thought Kubernetes had everything to do with containers. And yeah, we already know about executing code. Language of your choice with Azure Functions. So this is the Lambda. This is what AWS Lambda is. They call it Azure Functions. So if they ever ask you, what's the comparable thing in Azure that is Lambda in AWS? It's called Azure Functions. This is it. This is like Lambda. Even got a logo that looks like the Lambda logo. Serverless compute. Yeah, this is it. All right, so yeah, CI/CD pipelines for hub functions. This is key. This is pretty cool. We didn't see any of that over in AWS, but developing an application that's serverless and then create this continuous integration, continuous deployment pipeline for those things. That's a nice combination. Amazon has a CI/CD pipeline thing. They didn't tout it because I didn't see it. They've got it, and I'm certain they have it, but this is a very nice functionality to have. Continuous integration, continuous delivery with Azure pipelines. So this is basically Lambda. Security. Remember how we were talking about security with our assignment here? Ackles. How do we do security here? Built-in security monitoring. It's exactly what we need. Security. Okay, let's go performance. Grant access to that patient right here. See that? This is an ACL. This is how you do ACLs in Azure. And you can use Azure Active Directory, which is just a nice thing. Let's learn a little bit more about Key Vault. This is a way to manage ACLs. These are kind of like ACL policies, frankly. I don't think we're going to bring up ACL here. Let's see. This is the definition of how you set up ACLs in Microsoft Azure. Access restrictions, or they talk about entry points. And entry points up in here. Once you create an ACL policy, you apply it to another device. Right here, it's called the network interface built for Lambda. So that's kind of what's going on right here. App service, and the interface. Well, it's just a good thing. You know, we didn't talk much about ACLs with Amazon. Serverless Kubernetes, this is quite interesting. Workflows and integration, serverless API management. This API management. This is interesting because remember how in our Amazon thing we had that API? Here you can actually manage these APIs. See this hybrid multi-cloud management platform? That's pretty cool. This multi-cloud thing, this literally means it can be, when it says multi-cloud, it means Azure and Amazon Web Services, and Google Cloud Services. When they say multi-cloud, they're going, and they're saying we can go across clouds, manage APIs across clouds. In addition to Azure, deploy the API gateway side by side. So this is quite cool, multi-cloud management. We didn't even look into that in Amazon. Well, it's not really pertinent. Well, it's kind of interesting. It's not really, it's like pertinent with our architecture. And this has some cool stuff in here. So this is the app service. So I don't remember a corresponding thing in Amazon. This is kind of interesting. Amazon Web Service. Migrate ASP.NET maps and minutes. Oh, this is so cool. Let's scale web apps on a fully managed platform. Azure Functions, that's Lambda. Visual Studio App Center, wow. Yeah, Visual Studio, we can build, test, and release. Wow, that's pretty cool. This monitor. Man, I'm impressed. Start free, it's nice. This is basically Visual Studio up in the cloud. And we could probably build, test, and release visual, Azure Functions probably with this. So we looked at the security already. Let's look at pricing. Free tier. Whoa, man, this is kind of, they're pressing on my buttons here. Okay, start for free. Oh, 30-day trial. Build, analytics, crash reporting, distribute, page your app grows, $40 a month. See, look at that. Isn't that nice? 99.9% availability. I like that. Okay, so that is, okay, so onboard your first Mac OS. Wow. Wow. App Center. Nice. Okay, so pricing, get started. We already, yeah, it's all pricing, customer stories, resources, customer stories. Different companies using it. I'll ask questions. All right, so we got Azure App Service. We know what that is a little bit now. This Kubernetes service, we just saw that a second ago. SQL. We don't want SQL. We actually want, what about a DynamoDB type thing? We know that there's a correlation with Lambda, but now what about DynamoDB? Dun, dun, dun. Okay, Microsoft does have an answer to DynamoDB. It's called Azure Cosmos DB. Fully managed database service, multi-master replication. So this literally is a response to Amazon DynamoDB. A model, key value pair. Lots of different ways of querying it, which is interesting. It's open source right there. See that? Other notes. Okay, so we got no SQL going on here. This is exactly what DynamoDB does in Amazon. Let's see. Okay, so is there something correlating? Yes. Is there a free version? Yeah, free thing, customer storage, pricing, and so on. Okay, now we figured it out. Microsoft does have Azure Functions. That correlates with Lambda. And they've got Cosmos, which correlates with DynamoDB. So the functionality is there, both for the architecture that we're interested in. Serverless for the programming, our API, and then serverless for our database too, because this is a serverless database. So Microsoft's got an answer to both. What's it going to come down to? Pricing? They got free tiers. How do you choose between Amazon and Microsoft Azure? Question is, I don't know just yet, because we're not done. Got one more to do, which is dun, dun, dun. Google Cloud Services. Okay, the third player, major player in cloud platforms. Does Google Cloud have a database like DynamoDB and like Microsoft Cosmos DB? And the answer is yes. It is called Data Store. Here's a key value store. They don't have key value. Wow. See, this is what I was noticing about the data store of this database. It not only had document and key value, but it also had this graph DBMS. I'm not sure what white column store is. DB Engine's ranking in the trend chart. What trend chart is that? 16th overall. Look at that, number 2. Look at that, number 2 over here, 24th overall. Looks like Google Cloud is like behind. This is the thing I want to look at. Okay, DB Engine's ranking, trend of Amazon DB versus Google Cloud versus Microsoft Azure in popularity, 2013. Look at that, Amazon DynamoDB is just hanging right up there. Microsoft Azure is coming up, started 2 years later. Look at that, Microsoft Azure is making a nice climb. Cosmos DB, I should say. Google Cloud is struggling. They start at the same time, look at that. Can you believe it? So right now we're seeing that Amazon trend chart, website, technical developer, initial release, whoa, 2008, around that long. Schema free, yep. XML support, a big no. There's no yes in here. That makes us think, oh, our application, we've got XML data, we're gonna have to convert it to JSON. Secondary indexes, SQL, no. SQL query language, that's interesting. Yeah, RESTful API, we like that. RESTful API, we got RESTful, we got a JSON API. Look at all the APIs here. No wonder they're doing well. That's nice integration right there. Wow. Programming languages. Perl, Python. That's the next programming language I want to get into, Python. Yay, Python. Node.js, I'm not surprised. It's funny, they don't have Node.js. Microsoft does. Node.js is created by Google. Server-side scripting, no. Okay, in Google App Engine, interesting. Wow. Triggers. Yes, callbacks using partitioning methods. I don't even know what sharding is. Replication, map reduce. Okay, this is, remember our ATL conversation out there? ACL, I meant to say. ACLs? That is right here. User concepts, access rights for users and roles can be defined via the AWS identity and access management. Now, I haven't spent a lot of time on that. That part of this assignment, ACLs. Let's hold off on that until we decide on which one we're going to go with. Okay, so Google Cloud has data store. Okay, I don't even know where data store is in this list. Data flow, shell products. Still thinking. Data store. Up. Well, all right, so we see that there's a NoSQL database you can get through the data store. It's not doing as well as the other two. It's solid curve there. This is interesting. And then here, the other thing is, does Google have a comparable thing to Azure Lambda? No, I would say Amazon AWS Lambda or Azure Functions. And the answer is yes. Guess what it's called? Google Functions. How about that? Google Cloud Functions. Wow, got their name from Azure. Comparing serverless providers. Wondering which serverless provider is right for you? Yes, we are. Read this blog to understand and analyze the comparison between AWS Lambda versus Azure Functions versus Google Cloud Functions. Get to know the current version and compare performance, security, pricing, and scalability. Wow. Man, all we had to do is come to this. It's kind of nice. I'll put a link to that in our chat. Kind of nice comparing it, just like that. Let somebody else do the comparison. He's got to do a spell check. And then take this one. Put that also in our chat. Okay. See this right there, IAM? That is exactly ACLs right there. Granularity of IAM. Huh. Yeah, they don't even have it going on. What? When's this written? 2019 sometime. Persistent storage, completely stateless. I love that feature. Oh man. That means, you know, roll back, roll forward. I mean, roll back in any point in time. Logging, CloudWatch. Oh, that's weird. 900 seconds. That's like, what? It's a long time. No limits. deployment, zip upload. Let's see, scalability, orchestration. Okay. Well, so Google's got it. Azure Google Functions. You can see a little correlation comparison between all those. Let's now talk about, let's make a decision. We're going to go with Amazon DynamoDB for our storage, or Azure Cosmos DB. That's impressive. April 2020, you're closing in, man. This is so interesting. Microsoft's done so well with this particular database. And I think it's because overall 24, document storage number 3, so they're right behind. So they've got Graph DBMS, key value prices, so they're right behind in the strengths of DynamoDB. They're right behind document stores and key value prices, but they also have Graph DBMS, they're number 2, and wide column stores. Wide column stores. See, I actually don't even know what these are, what a wide column store is. Means of ranking. Stores. What's this up here? Cassandra. It's a white column store. HBase. Look at that. Cosmos is just cranking, man. Yeah, let's see. I don't even see Amazon in here. What is a wide column store? It's a type of NoSQL database. It uses tables, rows, and columns. Unlike relational database, names and format can vary from row to row in the same table. Whoa. It is a two-dimensional key value store. That's interesting. One dimension is one thing, but 2 dimensions, key value store. So we have key value store here, but this wide column store is like a 2-dimensional version of key value store. What does that mean? Ah, that's kind of interesting. Wide column store can be interpreted as a 2-dimensional key value store. Remember what a key value store is? We've got keys and values, JSON, pretty much. But interesting. I'll bet you that's helping this trend. I'm helping this definitely. That right there is probably because of the key value store, the double column store functionality. It's probably what's helping Microsoft. Do we need it? I don't know. At this point, I would say I don't even know. This Cassandra is the thing it's open source and it's free. This is the thing that's really the this wide column store that's doing so well. I think you saw this right here, Cassandra right there, and then the trend chart. Not that one. This one. This Cassandra here. It's wide column store. Do we need a wide column store for our application? No. Let's see. Where was I? Right here. What is a good application? Google's big table. Well, that's weird. No, wide column stores, they say Amazon DB, and yet in this thing here, they don't say wide column store right here. Huh. That's weird. Big tables from Google. I see there's Azure tables, so this is wide column store. It's funny they use the wide column store to describe Azure tables, and yet over in this here, they're saying Azure Cosmos DB is the wide column store. So which is it, Azure tables, or is it? See, Azure tables. There's Microsoft Azure table storage. That's a little different than the Cosmos DB. This Azure tables, that second one. All right, so back to the decisions. Decision. What should we go with? Amazon. Let me hear it. Got to hear the round of applause here for Amazon. DynamoDB, Google Cloud, Microsoft Azure. Was there migration from Microsoft Azure? I'm going to throw out data store. Forget that. It's between these two, Microsoft Azure and Amazon DynamoDB. So those are migration services. Not sure. I don't think we talked about this. Microsoft Azure Database Migration Services, and you can start for free. 2. The Azure account. So, okay, so we're down to these two. Down to, get rid of Google Cloud. Down to Microsoft Azure, Cosmos DB versus Amazon DynamoDB, and we'll inherit the Azure functions if we go with Azure. We'll inherit the Lambda if we go with Amazon. Let's see here. Microsoft really wants this market big time, man. They want to take it away. Look at jobs. This is really interesting to have a job show up here. That might be an interesting question. Let's look at that. Let's look at Indeed and see. Let's look at some of these jobs. Let's get a feel for the market by how many jobs are out there. 109. And this is going to help us decide which way we want to go, because the more people using this technology, let's see, Azure functions. It's not a lot, by the way. 109. 232 for using Azure functions. Okay, now let's change gears and let's go to Amazon. Amazon Lambda. 108. I if I took those out. It's fine. Right. See, 1,144. Let me do the same thing back with, let's see, Microsoft Cos functions. Let's see. Whoa. I don't know if that's a fair comparison. Let's see. That word functions is so generic. I don't think it's a good comparison. When I put quotes around it, I get down to like a handful. This is not working out exactly how I'd hoped. See, Amazon, what was the other one? Dynamo? Aren't there 2 jobs at Dynamo? Let's run the DB there just to see. See, I just added this DB right there and picked up on 1,747. Your Lambda. 1100. Microsoft Cosmos 323. Oh, no. Cosmos. Kind of looking like Amazon is a more sought after skill set. Yeah, let's just go with Amazon. It just seems like there's a lot more opportunity. So, decision made. We're going with Amazon. Amazon DB, Amazon DynamoDB. We're going to use Amazon DynamoDB. We're going to use Amazon Lambda. Basically this one here. Multi-cloud. I have to keep our eye open. It's hard to know when you go multi-cloud. It's just hard. So anyways, now we've made a decision. Okay, we're going to go with Amazon architecture. Now let's go look at this right now. This is where the discussion of ACL is concerned. So I'll talk about this now. Okay, so what this is identity and access management. It's going to solve this problem right here, ACLs. And this is how you basically manage users. In Microsoft, you use Active Directory to manage this. So this is kind of the correlation of Microsoft Azure or Active Directory to AWS. So you can just drill down right to the specific resources. So you manage their users and their access. Let me grab this as a link, put it in our chat. Users, groups, permissions, auditing, password, all of this is just really great on all of the possibilities of stuff you can manage and at what level. So create the users. This is something I want to talk about, these roles. Looks like the roles are associated with EC2 instances, which kind of surprises me. So I have a little screen on this. IS2. Let me just double check usage of IAM with DynamoDB. So there is IAM for Amazon DynamoDB. Set up users. You have management console manages. So these roles are really interesting because you can create a role, and this correlates directly to this conversation right here, rights management. Okay, so you got this role here, and you define the role, and you associate all sorts of privileges with that particular role, and then you assign roles to people. So this is kind of nice. You define all these roles and these policies. So these, like for example, back in my other job, I was release manager, and we created a role called release manager, and we gave that manager all these rights, all the things I had to be able to change, and all the things I was not supposed to change. So both of them. And so roles are a way to solve this ACL. You define all these different roles. So creating IAM roles, delegate permissions, and so on. So this is how you manage the ACL permission. You define these roles, and then you assign the roles, people to roles. So also Lambda can handle it too. So that was DynamoDB. So you can use IAM with DynamoDB, and you can also use IAM with Lambda. So so this is how you assign ACLs to a particular function, like a Lambda function. Read all informations, develop functions, and these are different actions or that you're calling into. Person has read-only rights. This is an example of policies that you put in place that are associated. So this is actually how it's encoded. These policies are encoded like this, and this is how you define an ACL. So you define these policies associated with users, create roles with these policies, associate them with users. You can create groups, put people in groups, whole amount of groups. The groups have inherent roles associated with them. So anyways, so that's how you would solve the ACL challenge right there using IAMs with AWS Lambda. All right, well, and you know what? I've taken all this time to just do this comparison, this analysis of what to do. I think that this has been beneficial for you to essentially write a plan, a data source migration plan. What I want you to do is take all of the process and synthesize all this logic that I've used to make these decisions, and then come out with your recommendation. And I'm fine with you recommending AWS with DynamoDB and Lambda. Okay, I mean, that's kind of what I concluded. So, and that's fine. And so if you could write your paper, it doesn't have to be 5 pages long. It's so long. Just do an analysis of what I talked about. A summary, kind of an executive summary. Try to get 2 pages in. If it's less than 1.5, I'll be like, you should get 2 full pages in, including the references. Throw a couple references in there if you could. Anyways, and let me know how this goes. Send me a text message if you have any questions. All right. All right. I'm going to call it. And thank you very much. It's been a great class. I hope you enjoyed taking this class with me. Our cloud services and mobile connectivity, mobile computing. Excuse me. All right. So thank you very much. I appreciate it. We'll talk to you soon. Bye-bye.